All right, we're going to go ahead and get started. Welcome to the TEEP working group. This is the first meeting of the week, and so we want to call special attention to the note well. We'll leave this on the screen for a minute or so here. Make sure that you read the note well. It covers all the meetings during the week, anything that's part of the IETF. Out of curiosity, how many people is this their very first TEEP meeting? You raise your hand, the very first one. Excellent, thank you. Welcome, we're glad you're here. Thank you for coming. All right, for note takers, I believe we have one note taker right now. Thank you, Ned Smith. It would be helpful to have a second note taker as a backup. We keep notes in the Etherpad, which is the bottom link there. You should be aware that if you go to the, we just learned this, the IETF agenda page has a link that takes you to notes. That one generated a different link than this one. So we're using the one that's on this slide. Right? Make sure you use this one. But is there a person that'd be willing to be a backup note taker for us? Otherwise, the chairs will have to watch it. Okay. We do have Meet Echo. We will be watching the Jabber room. I think we have somebody else watching Jabber too.
No, we need somebody.
Okay. Is there anybody else who wants to watch Jabber? We do have a screen up here. Thank you, Ben. Okay. Great. All right. Here's our agenda for today, and I will mention, in case you didn't get the notice, it's been already broadcast, our Friday session is moved to tomorrow morning. Okay. That means we have plenty of time. And so today our focus is on the architecture document issues, and these are just guesses on the time here. The time is flexible, and if we run long, that's perfectly fine. We have the time, and the item number 4, the transport discussion, will move to tomorrow if we need more time for architecture discussion today. So this is our current agenda for today. This is the agenda for tomorrow morning, same time. We're in a different room, but same time tomorrow. And so tomorrow we get into protocol, and starting at 11 a.m. tomorrow, we will have the discussion about attestation and the relationship with the RATS working group. Okay, there are some RATS participants that we want to be in that discussion, and they have a conflict during the first hour. And so all the attestation stuff will start at 11. Okay, and so as you'll see right now, all the times are just estimates, but you'll see before 11, those don't add up to an hour, right? Which is why the transport discussion overflowing to tomorrow is perfectly fine if we do that, right? We will be able to have time for non-attestation related stuff during the first hour tomorrow and attestation during the second hour tomorrow. Okay. Any agenda bashing? Any comments on the agenda before we actually begin our agenda? Here's our agenda for today. Does this look good? Okay. Then with that, we are going to go to our first presentation, which let's see, Ming, you're gonna run it? Okay, we have a little X here because the camera's pointing. So let's move to the architecture slides. There you go.
Okay, works well. Here's my agenda. I will going to talk about 2 areas. One is a document update. One is go over the issues. Some issues we have resolved, but I have not updated document, but I will go through them.
Let me try this.
Okay,
try again. Let me try again. Okay, this works well. Document update. We have a brief document update. 3 changes from .2 to .3. Major one, still the major one, it's a security domain is removed from document as it's not a dependency anymore. So this has been an important topic, has been discussed in last several working group, and last few months, and we have interim meeting, and from last IETF we have a resolution, and we get agreement, so we removed explicit dependency. Secondly, we add a TEEP agent in TE as an entity model. It's inside TE. There was some terminology clarification, what it means agent, what it means broker, and so on. So that TEEP agent. I have some more slide, one slide each for each of the changes, briefly summary there. And TEEP broker and TEEP agent and agent is more aligned and clarified in a document update. In addition to these changes, we had a interim meeting in May 17th. Editors also have a working session. So we worked blocked the entire day. And we worked through several important topics. I will have some update on that next. All right. So here to give a quick glimpse of the issues. Totally currently listed 64 issues for architecture. Right? Before IETF 104, we closed a dozen issues resolved. And in the last 3 months, we closed to 4. And these 3 are ready to be closed. We just say after review here, we're going to close it. I would consider there's no more issue. And then they have this is the other issues. This blank font is something I will go through, have some more updates. These are other issues we're continuing to work on. Some we have not made update or have not discussed much. But like this one, so editorial changes. This should be not complicated. So the complex ones or major ones we will briefly touch on today, and we give some discussion. I'd like to get feedback. So that's the main intention. So next, I'll go through this one for the interim meeting and a working session update. We hosted this in May 17th at Semantic office. We have virtual meeting about an hour. Then have a working session by editor and the chairs. And we was David and Nancy were all there. Issues we discussed, and there was some solution proposed for the issues or problems. There's a list here related to architecture. There's some also product discussion I do not list here, but it is more related to architecture. First, I want to talk about the security domain. Right? Finally, said, do we remove or still wait more? Need more feedback. So we discussed security domain, TEEP agent into architecture, talk about terminology alignment. This was not email thread actually after the working session. From that working session, we said, okay, now what do we call it? We mainly spend time whiteboarding the end-to-end flow. Then look at where's a protocol gap, where's the architecture gap, what the interactions, where to have complete coverage. Also face-to-face brainstorming. So what's the API we should put there? And a very actually quite a useful exercise. We discussed the TA distribution by client app. Remember earlier we have a issue that TA can be distributed by TAM or by a client app. But when the client app, how it should be done. And we whiteboard it to have a workflow I will talk about here. Actually, it's a good example which illustrates the interactions among components. We also discussed the topic about the end-to-end security between server provider and TE. Because service provider won't deliver some trust application or special IP protected algorithms on to in TA. How is there a privacy concern? Is there an IP disclosure concern? How to address that? So I have some slide on that one. So next I go through this topic first, then go through the issues. Right? The issues. First one, this one. So I mean, for people in particular for first time coming here, early draft has been assuming there is a security domain for trust application. You install trust application into a trust domain, into a security domain. That was inherited from global platform concept. I have security domain as part of their secure element. But when not brought to broad TE, they now say, is secure domain required? And Hannah said that earlier, this issue, so what's actually meaning of that? What secure domain used for? It's isolation scheme, it's a management scheme, or it's used for provisioning. So what's the purpose? But if we have SGX and different TEs, is that required? Is that necessary? So the consensus feedback come back and say, no, we don't see it has to be a requirement for trust application in broad TE, different TE kinds. So what we decided was that TEEP doesn't need to expose secure domain APIs anymore. So it's decided we just have a trust application management. However, we leave that to implementation. So if a TE, like Global 5 TE, they want to use such secure domain undercover, it's fine. They can implement TEEP protocol and TA management API, like install TA undercover, they can assign an implicit secure domain, identify whatever they decide. But for protocol level, we will not interpret it. We will not assume there's such thing, right? It's implement dependent. But for other TEs, they never have the concept. They continue, they just manage TA. Yeah. So that's an important decision. I think this will be one of the major decisions in architecture level I consider, because a very big change, right? Big change. We removed half of APIs protocol because of that. Also removed a lot of key management, right? Earlier there was more overhead of key management, right? Now you have a key associated with secure domain shared by SP, owned by SP, who owns it? So that's complexity. So status-wise, architecture document has updated to remove the secure domain as many pieces, but so somewhere we may have a word we have not fully removed, but the decision. Product document also, Hannes will talk tomorrow. Right? Version 1 we didn't make much change, but the version 2, which actually no more SD. And the protocol is a schema related. Earlier, secure domain is a first class citizen, right? They have identifier, name, key, and so on in schema. Those now will be gone. Yeah. So this is this one. Any have comment or update?
This is an issue that we believe we had consensus for at last IETF, and now we're just reporting the action has been done in the architecture document, and so I think the editors feel that this issue is now ready to be closed.
Yes, issue 7, I think they're closed. All right. Okay. Yes. Also, the document has been done. Yeah. So next one, this is actually very simple. It's introduced, and then this thanks Dave and a lot of good feedback come back and say, earlier, I mean, very beginning, we have the, very old time, okay, first draft is we have the agent, we have the OTIP agent, or TEEP agent. Now we clarified to say, we have a TEEP broker in the REE, in rich world, because you need to handle transport layer, right? TE does not have network capability. So you need something in the REE to do that job. Then this REE need to talk with TE. Then do we need something inside TE to handle the TEEP protocol? So is that such a concept? And this is formally formulated. This we call it TEEP agent. So now we do have an architecture component called TEEP agent inside TE, which would text the messages from TEEP broker. Right? So this now is introduced in architecture doc. It will propagate to the product document and transport document. Terminology-wise, I have next one. So this one is in a 03 document. There's two issues you can see. Earlier there was a couple issues related to this. What you call it agent, you call it broker. When you call it agent? When you talk agent now, it means it's a entity inside TE. And how it's implemented is implemented independent. Whether it's a trusted application, special trust application itself, maybe special system trust application, or maybe not, depending on TE. Yeah, but this a component conceptually represent that. So this one, next one further, you can see as I get better. So now you have client side, device side, you have TEEP broker in REE, which handles networking to remote service. Talk with a local TE in a device. So you have TEEP agent. How about flipping time side? Time side. This one I say credit to the David Thaler. He said we have earlier TAM. TAM may run also in TE. Well, don't require TE, right? But say you may have SGX, you have also TE. And you have component, it's web server. We know HTTP protocol, you have the web server. Do we need to formulate some conceptual module there? We can give it name. Yeah, my question come back, so its name, TAM, we call this TAM broker, right? Is broker right word? We may change it later. But this is like your feedback. Okay? So far I say we may call this TAM broker symmetric to this. You have agent, you have TAM broker, and then this TAM service side, we have this TAM engine, right? Management engine like this. And then you have a web tier or transport level. We talk about transport, I don't mean necessarily HTTP, TAM broker. So that's from architecture document, my question more come with, so should we add this entity into the architecture diagram, into the architecture document? Yeah. And Dave, tomorrow, today, okay, later, he may have to do one more in a different stack, talk about this one. For product document, well, definitely it will be must be mentioned. Then do we push back? I didn't mention for the current document, we did formulate that, right? If you introduce the update, we just say TAM service, we talk with TAM service, it's one box, right? It's a black box for the moment. We define the message protocol. So this is up to discussion. I was thinking, okay, but Dave,
I think we should defer this question until we get to the transport discussion, because I'm going to expand that question to a different question. Any more questions that are interrelated, maybe is the point.
I'm good for that.
So reserve judgment on this one, answer this one after answering the other questions that will come up in the transport discussion. So
okay, so remember this question, so now it's more for architecture side, whether promote into the architecture level. I think that's the central question here, but we may follow up when that bring up. Then the next one about the protocol landscape, I was a protocol landscape. We started with our architecture document, then we started with the protocol. Say, main protocol is a message protocol. We have message exchange between TE and the TAM, right? To manage your trust application, install TA, delete TA, and the query status. But along this, then we introduce architecture component. We have TEEP broker and TEEP agent. How do they talk to each other? Interoperability, right? Then they need an API. I call this TEEP agent API. We have this definition in OTIP protocol, okay, in that protocol. Now the question says this one, where should be defined? We editors have a discussion, so we may define this in architecture doc, not in a product doc or transport doc. That's one way, because this can be shared no matter what protocol you define in this message. But this one just between rich word and IE and the TE, that's the same API. We may do that. That's one proposal. Okay, I put it here. TE agent, this API defined. Transport protocol, David has IFC already for that one, right? To support default HTTP, the first one require 3. 4, between client app talk with TEEP broker or some installer, TA installer in the IE to trigger some install TA. Do we need to define API or not? So far, we say no. We leave that one, say how that interact with TEEP broker may be platform dependent, right? platform dependent, whether it's IoT device or Android or SGX. How that done, we may not be able to define that. Right? It's outside of our control. So we say, no, this one intentionally, no definition here. Another side, if we introduce time broker concept, you have time. This also link here. Do we need to formulate some API? Or this one leave as one black box. They just define here. They intercept the APIs called here. This will be RESTful API, I assume, let's say, in practice. Then this one internally send to it, process message similar to this side, right? The API call, this will process the message, whether SIP or JSON or whatever. So far, we just consider 1, 2, 3, we would define the protocol. 4 is no, 5, TBD. Yep, let's update. So we may have follow-up discussion that one.
Speaking as an editor of the transport protocol document, so pretend I'm standing over there. My current opinion on your question about whether the APIs are in here, obviously the line is in here, right? The line is already in the document right now. I think the question is how much detail do you go into about what the APIs are that are expressed in that line, or is it just some general statement about these APIs allow you to communicate between the two and pass messages, that sort of thing. And so right now my opinion that I'm going to express is that I think the level of depth that you go into should be the same between 2 and 5. I don't have any opinion on the amount of depth that belongs in the architecture document as to whether it's very hand-wavy or whether it is a list of the names of the APIs. I have no preference there, but I think whatever the answer is for 2, I would prefer that the answer be the same for 5.
Okay. All right.
I'm so far away.
What about the door?
So, Sorin Fajbis, my opinion is that the one inside probably is needed, at least from what I understand, for some use cases. The other on the right, it's kind of internal, in my opinion. It's they shouldn't be linked together. I mean, I don't think that if that one is included, that one should. I don't think so. I think 2 is to stay on 5. I have no opinion.
Okay, so quick for the note takers.
Yeah.
Please spell out your name.
Sorin Fajbis.
Okay.
Yeah.
I learned.
You're talking about the interfaces.
5.
You're referring to 5.
5 and 2.
5
I think 2 is important. And 5, okay, it could be good, but I don't think it's needed because it's one
service, because this will generally will be a software service.
It will be a separation
somewhere
inside the module somehow. That's my opinion.
Mm-hmm. Thank you, Darwin.
This is Dave Wheeler. I like the symmetry between adding 2 and 5. I think it's important to define them both. I agree with the last person. It's Sorin.
Sorry.
Sorry, that's hard for my ears.
Sorry.
Okay. But the question in my mind is whether the APIs are normative or not. Clearly, we could get away with saying 5 is not normative. I think it's harder to say that 2 is not normative because you need to have the interoperability between software and TEEs. When we say 2 is normative, then I have a hard time saying 5 isn't. For the same reason, it creates a lack of symmetry in the protocol and in the architecture, and I think that's difficult. So I understand the desire to not be normative in the TAM side to allow for more flexibility. I don't think it hurts much to have it be the same as number 2. So I'm leaning towards saying both 2 and 5 should be defined and they should be normative. But I'm open to having that discussion. I understand the
I'm in
concern
line.
of defining too much.
I'm jumping in line. This is Dave Saylor. Go ahead and get in line. You're in line after me. I didn't want to run through me, so okay. The purpose potentially of having the names, this is of the APIs in there, is the names of APIs is what is used to correlate behavior in the TEEP message protocol spec, number one, and line number one, and behavior in the transport protocol spec, line number 3, right? If you use the same name for something which says, I invoke this event, and the one says, I react to the following behavior in response to this event, right? Then you can correlate the information in the two specs, they fit together, okay? And so line number 2 is a way of doing that for the TEE device side of both specs, okay? Line number 5 is a way to coordinate between those two sides of the TAM side of those two specs, right? So that would be the benefit of having the literal names in there, is just to say, if there was an update of either of those specs or some alternative spec, so let's say an alternative transport spec was defined that was not HTTP, right? If someone was going to do a different transport spec, they would say, if they were normative in there, as we were suggesting, then a new transport spec that was a non-HTTP would say, and here's the names I have to specify the behavior for, right? That would be a requirement if you made it be normative, right? That's just my response to Dave saying he likes it being normative. I said, I personally have no opinion either way, but if you do that, that would be a benefit.
Yeah,
So,
I can see that help. Oh, sorry.
Sorin Fabish again.
As editor of the transport spec, not as chair.
Oh, sorry. Sorin Fabish again. I don't have a strong opinion like you, Dave, but I'm thinking of the case when I have multiple TAMs, and I'm kind of not sure that is the same. So I don't know if it's important to have the separation inside each of the TAMs or not. That's what I'm a little not clear. So for this simple case on one TAM, maybe it's okay to separate and have both, but for multiple, I don't know. Maybe it should be normative for that case. I don't have an opinion, but that's.
Okay, so I'm going to speak as chair. Okay, so from an architecture perspective, I do think it's important to describe the functional workflow. When you guys speak to normative versus informative, that gets to the question of what does the working group move forward towards definition. And so I want to make sure that we're clear, and I'll have our area director chime in to tell me if I'm wrong. But in the IETF, we talk about the interfaces, and so the data structures and the schema to allow these interfaces to relay information. And so you could define transfer protocols or transport protocols. I'm not sure here whether number 2 and number 5 would really be in scope for us here in the IETF.
Okay.
I will be open to suggestions of how it could be in scope. Right now, the way I'm looking at it, to me, it's not.
Even 2 is not.
Even 2 may not be in our scope.
So, hoping I don't have to walk over there. Does it have to be
Echo can't hear you.
informative? Can we be informative on those?
So again, the architecture spec, to me, describes a workflow, right? And so I guess if you're trying to ask, so the question was, can it at least be informative, right? And so from an architecture perspective, I guess I'm not making a distinction of informative versus normative, unless you're saying this is a hard requirement that has to be in the charter for TEEP, and we must define these within TEEP. Does that clarify it?
The question is, what do you decide? Because for me,
Mike,
You need to get to the microphone.
Mitelko needs to be able to hear you. So I'm Dave Saylor. I'm speaking for the participant mic from anybody that's remote. I think that the APIs are in scope. I think there's various analogies in the IETF for abstract APIs, which these are, if you're familiar with that term. Other examples in the IETF, GSS API is a well-known RFC that was an abstract API. The TAPS working group is chartered to do various APIs. And the abstract APIs means that you don't specify how it looks like in a particular programming language, because that can completely vary. What you specify is some name for it that can appear in a document, which may be different than the name that appears in a particular programming language, and the meaning of that API, right? Without specifying, oh, and this thing has to be an integer or something. That's not abstract. That would be a concrete API. So IETF does those when you need to correlate behavior between two different specs, like two different layers, like between TCP and the layer above TCP, right? It says, here's the different events. A connection comes in. I lost the connection. Message arrived. Things like that, that are events that TCP exposes. In some sense, that list of events is an abstract API. That's what I believe is in scope here. That's what the protocol document and transport protocol document, the TEEP message protocol, OTRP, and the transport protocol document talk about. And I think it's in scope for the working group, but the level of detail in the architecture document is what I do not have any strong opinion on as to whether it is detailed or no detail or anywhere in between.
So Rindal again, my problem with this is, let's suppose you remove both 2 and 5, right? I'm not sure that you can have all the, maybe it's not a direct protocol, but it means that a TAM will talk directly to the TEEP agent. So that's where I'm a little, I don't know that's correct. So the question is,
not direct, the TAM direct to this, well, goes through this TAM.
I don't think that would work.
Yeah.
Okay, so
Ben Kaduk. So yeah, Dave is right. We do have some precedent for talking about the abstract APIs. Actually, we do specify what they look like in programming languages in at least a couple cases, but that's sort of a side note. And in terms of in terms of what to do for the architecture spec itself, I sort of agree that maybe it's still unclear about whether we need to describe things as specific abstract APIs, or if we could talk about in more generic terms, this is the sort of information that you need to convey between these two actors. And exactly how you do that will be defined somewhere else, possibly from this working group, possibly implementation specific. So I mean, we need to consider what the architecture looks like in terms of which pieces are going to interact. And what sorts of things they might be doing. And I'm open to having the APIs described. I don't know that there's a clear, obvious one way versus the other. So I'm excited to hear people discussing it and seeing what they think.
Okay.
Yeah, I think we can.
Yeah, I'll move to next. Yeah, and I have actually later I have one for use case, one example illustrate more what the APIs may be needed, or at least functions. I say what kind of function we may need to describe, and at architecture level, we want to say at least where they are, and concrete APIs will define a specific protocol. I've talked about a few slides later, and I'll move up here. So next one to talk about this, actually, it's here. Just this one, it's actually this one illustrated. This one I moved earlier already. Okay. This one illustrate some kind of functionality involved. Right. This architecture level, but it is more like a protocol spec, but involved because it's I want to show you one use case we discussed. When you install TA, where the TA binary is bundled inside the client app, or maybe in system already. It's not always distributed by TAM. And this has major impact on the APIs. What functionality you have, a support, optional, required elements, arguments, and so on. In the first draft, we assumed TA binary is always from TAM, from service. Later we say for like SGS others, that TA binary not necessarily always from TAM, and how to support it. And we get a little bit more thought during the working session in May. So the flow looks like this. You always start with client application, right? Client application has a manifest file. It says, this will use refer to suit as something with 2BD. It says client app depends on one TA, and this TA can be downloaded from this TAM URL or not download. Make contact with TAM URL for authorization. Okay? That manifest file. And then client app will pass this to TEEP broker. By the way, this can be from an installer, dependent platform, right? Not necessarily application always make call. Application just call installer, I need that TA. That installer may call TEEP broker, say, you do that job for me. And what that means says you have something conceptual, say request TA, okay? I need a TA, here's a TA's identifier. Also, I say I have binary not. In this case, binary is equal to true. This TEEP broker first contact, TEEP broker will talk with a TEEP agent locally. Is that TA already installed, right? If you installed it, you don't need necessarily go out, right? But so that the first thing called to TEEP agent, now you need a function how to call it. That first API is a request TA, right? Or query TA, whatever you would call it. Let's say request TA, TEEP agent inside says, is the TA already installed? Yes or no. Let's assume empty. No, I don't have TA. Then now for this one, it's a TAM URL override policy, we call it, right? So it's a policy override. So this goes to TAM URL, but then this one's whether it has known TAM earlier, the TAM already contacted in the past, I trust the TAM. Then we may shortcut it. If it never know that TAM, right? You give me TAM, I never know that served yet, right? I don't know what it is. I may not trust it. I will not leak my information. What it does is this one would go back to here. I tell you, here's the TAM you go to contact. So call back TEEP broker. TEEP broker is now talk with TAM. Okay, now we call it step. First contact, what to call it, right? First kind of what to call it. You need whether API pass, RESTful network pass or name, we call it connect. Then maybe you saw some initial contact, whatever, you need this one. TAM come back and says, give me the device status. At the same time, it assigns a message so that it can tell the tell the TEEP agent who I am. So T can make a decision whether I will allow the TAM to do something in this device. And to make that call, TEEP broker will pass the message TAM gave to the agent, what to call it. Well, I give generic name now, process TEEP message, right? It's just API. So look, those are abstract APIs, abstract interface. How do we call it? That's the work we just discussed. So now the first one is to process this one query. Now this one you say, okay, I'm going to remember this one request to install TA. I will put in a message. Query response, which say request TA is TID and this one's highlighted here. It's TA binary hash. Okay, by the way, this one you have local binary, and this generates such message is signed by TE key, and now send it back to step 8. Query response back, and now time come back and say, okay, this is device I trust, and I will say decide proceed to install TA. It sends the install TA command. In this TA command, it doesn't need to give the TA binary, right, blob, because TA binary is locally available. But what one thing does was, I was going to mention that one, we talk about is flow message. TA binary, why we send over, because TA is there, either have version or binary, locally client bundle it. TAM may say you have old version or you have binary I don't trust. So you give a TA hash, right? Hash or some whatever identifier or some data, you could tell the binary data about the TA. So TAM can make a policy decision. TAM may have a late version TA binary. Say this is the version you should use, not the one you already released, right? Because you may have the old version locally. The latest version may be in cloud. Right? That's the intention. So you say it's just workflow wise, is come back. Now you can install. One thing I want to point out here is the API. So now you see, now you have install command is a TEEP message that was signed and encrypted. By the way, for any security with that every message encrypted by TE key here. So that message encrypted. TEEP broker in the beginning is a dummy broker, right? All the network transport. You give data forward to TEEP agent. In this case, it does more than that. Because what the need to do is put an install TA message process plus optional TA binary data self. But that piece outside of time. Remember, it's outside of signed message. It is from IE, not from signed message from time. It's located here. Well, it's signed. TA binary signed. So anyway, TA binary is signed by who? By the service provider, not necessarily from time, right? Because who's deliver author, right? Who's the developer? Applicant developer service provider, signed by service provider. Actually, this we talk right tomorrow, right? This one about the sign and so on, some more clarification. So interesting, you have multiple entities by the SP time device all have the key and the certificates, multiple entities, right? 3 time key, device key, and SP signing key. Right? So anyway, so the point is this function here need to accompany that. TA binary is optional and pass to TEEP agent, not TEEP agent install as usual. It has a binary. It may retrieve binary from a local system. You may not give it to me. Maybe in a resource location, I already know. I will fetch myself. So that gives this kind of options, different variety, different use case you can see we need to handle, we need to address. So this will add some protocol complexity, but it looks all this valid cases we need to consider. So this was we have a wide whiteboard brainstorming by editors there. So this will be a flow. Any comments? Any?
If it wasn't clear, some TEEs may need the TA binary in order to install the TA binary. Other TEs may not, right? And so I think in past presentations in this working group, I think David Wheeler in his SGX one, he explained that SGX is an example of one that does not need the actual TA binary at install time. It only happens at, say, load time or whatever. You don't need the actual bits of the thing. Other TEs may store the actual TEE in, say, protected storage, right? And so that's why Ming says, if needed by a TEE, right? It's not optional. It's in one implementation, it would be there. In another implementation, it would not be there. It depends on the TEE.
Is there I just did a quick look at 03.
Your name, please.
Randy Turner with Landis & Gear. Is there a use case, or has it been mentioned about connections between across networks between a agent and something outside of the device, basically to multicast applications to multiple agents at the same time, or multicast? There is a section about IoT in the architecture document, and in my industry we might want to send down the same thing to thousands of devices. Doing them one at a time might be a little much.
So that's a new case to me. So far we consume individual device, one TEEP broker, maybe multiple, but TEEP broker may have multiple TEEP agent and multiple TE case for one device. But you say if one TEEP broker to the 100,000 multicast multiple devices at the same time, we have not considered that yet. Well,
okay.
Maybe, but others may thought about it. Maybe Dave, right? So, yeah.
Okay, thank you.
Yeah, but you brought up a use case. I think that was.
This is Hannes. So far, in many of the discussions, we talked about the transport that Dave put together on HTTP. What we didn't discuss, and maybe we should in the document, is that in some of those use cases, like IoT use cases, we're probably not using or in many cases not using HTTP as the transport, but something else. And there are indeed people who,
protocol here.
who use sort of a multicast distribution model, or at least something that is at the radio link group communication security. And maybe that would be useful to describe in the architecture document, even though those protocol mechanisms already exist, and we are only talking about transporting the OTRP messages on top of those existing protocols.
So you had, okay, if I interpret correctly, so you suggested here, even this transport layer, this one multiplicate, not here.
Right.
Yeah, we talk about this level, right? This one may have go out some multiplicast instead of this one, because this one is a more, no, this one. This is more local, right? More
yeah,
local.
so the client app in that case is the device management client app. So it's not really like there's only this app. And then the TAM broker is also the device management servant. So there's the underlying protocol that provides that distribution mechanism. And that exists already, has been tried out, and some people actually deploy that already. So
in our charter and our original BOF poster, we talk about there are many different ways to distribute the TA binaries themselves. And of course, there's many different ways to distribute the client apps. And so, example, in our charter we cover, and in the architecture document we cover what happens when it is bundled and what happens when it's not bundled. And in the last version, David put in like 3 or 4 different cases into the architecture document. And so here, if you talk about multicast distribution of, say, the client application, or multicast distribution of the TA binary that is bundled with the client application, that is orthogonal to the whole use of, say, OTRP. Because OTRP can work without transporting the TA binary itself. And so to answer the question about multicast, if multicast is done as just the binary distribution, which is not done inside OTRP, then it does not change anything on this slide. Right? Everything on this slide is about, sorry, you not switch slides. This slide is about what happens when you do bundle a TA binary into a client app, which is one of a couple of different use cases, right? And so if the client app was distributed originally via multicast, then so is the TA binary in this slide, okay? The communication between the TEEP broker and the TAM is still unicast, but that's about metadata and security keys, not about the distribution of the big binary, right? And so this slide here is still fully compatible with multicast because this is agnostic as to how you actually distribute the TA binary itself.
This is Dave Wheeler. I think the distribution of the binaries could be multicast, but our whole protocol is based on an attestation from the TEE to the TAM. So we could talk maybe in the architecture document about decoupling that more directly and using a multicast to push out a binary to many end stations. That probably requires us to talk a little bit about opening up a different type of transport, right, with a port that's listening on multicast. But in the installation, right, and authorization of a TEE, that's still point to point from TAM to TEE in order to make the attestation work. There isn't really a way to do a multicast attestation.
So, right. I'm going to speak up as a suit working group chair here. Well, I was joint TEEP and suit working group chair. Right? And so tomorrow we'll have a discussion about the relationship to suit as part of Hannes's OTRP presentation. The discussion of how you distribute binaries to things is something that I claim is heavily related to the suit manifest discussion. And I would invite people who want to participate in the, could I multicast stuff? How would I reference by URI a TA that is multicast or whatever, is a great discussion to take to the suit working group. And I see my suit co-chair in the back who just sat back down, so he's not there.
So I don't think we actually have to do a lot to enable that. I think it was useful to discuss this topic in the architecture document, that there are indeed other transport and the distribution of the binary may be done in multiple different ways. But I don't think it will require us to do new protocol mechanisms, because those exist already and have been used. Like, for example, we've been using this distribution mechanism in LoRaWAN, and it's not using IP in that case for the distribution. And I agree with the other notes that Dave Wheeler added earlier.
Yeah, I think that if just the binary multiplecast distribution itself, it will be a simple problem. But for the attestation, it's an end-to-end today. It's an individual device. You get a multiplecast will have a farm of devices. They have different keys, and we cannot do easily. Yeah. Okay. Okay. Good. It's like that we have some agreement. Okay. I will move on there. But this is a good illustration. You can see, hopefully help for this slide. So just overall where the functionalities we need to illustrate in architecture and where we'll go to the protocol specifications. Okay, that's more for that purpose.
So before you move off of that one, can you summarize what's the status of issue number 11? Is it already updated in the document, or is this a report that the document will then update to match our discussion?
No, this one is we discussed. We have not updated document. Yeah, and this one's not in any document yet. I think this one's particularly the TF binary. We do have this one. Architect document does mention we support TF binary client app. We didn't go to this level of detail, how and the impact and what considerations. Because architect document halfway talk about architect concept, halfway the requirement, right? What product document should do and others should do.
You want to talk about the privacy?
Okay. Yes. Thank you. So the mission label. So look at this flow. I think some product. There's one thing here. Actually, about this one. I mean, there's two issues related to this. There's this related issue about earlier we have number 9 to 10 about install TA in single pass. So we have multiple goals in architect design, make it efficient, right? Make it efficient. That means single pass. Single pass. What this by standard update for status wise, so single pass means today you need 2 round trips. You always start with time, query, what device look like, is TA there, what's there, then install TA and so on. But the efficiency is, can you just don't do 2 round trips, use 1 round trip, right? So that means you can start with TE, locally sign request, send time says yes, go ahead, come back. That's 1 round trip. So these are 2 issues related. Okay. Now come back to this one. The 2 issues here. This one need to handle in a similar way. Can we achieve that? And we come to this conclusion. I would indicate. Ideally, your client app, TP broker, talk with TP agent locally, yes, and you will sign first. However, you don't want to send your signed information out to someone, you leak your information, because you don't know the time yet. That privacy concern. Okay, no means you don't support it. You say no, should not, right? Yeah. So that's our.
Is the problem.
Yeah. Okay, that's the exact privacy concern we talk about. Say, because REE gave me URL. I will not trust that URL yet because I do not have the timing information yet. Then I will not give anything. So that's why I say, sign you could, but we will not. Okay, we will not give a signing information out until I know it is the time I can trust. Right? So for that reason, you can say that here's sign. I'm not going to give the signed data first in step 4. I only give maybe time URL. You contact 5 step. You do the first contact, verify, contact time. Time give you some back. Time give you signed data, give you a certificate. Now you can verify this is time I trust. After that, second time, I think product variation, remember that one. So, okay, subtle here. Second time, we install another TA later. The TP agent can cache a time certificate here. I already contacted time once in the past. I know that time. If you give time URL, give time identifier, I can now sign first in one single pass. So that's kind of a two protocol. This is a protocol variation. We want to support both, right? You got David, and then you have. Okay.
Yeah, this is Dave Wheeler. So from my perspective, there's two issues. One is privacy, and the other is the issue between multiple round trips to the TAM versus local storage. In my TEE, the way that Ming has described it, I can maintain a list of TAMs that I've authenticated before, and then I can use that to reduce the round trip. But if I don't have that storage, then I can't do that.
Yep.
So an alternative is to allow the TEE to be configured, or the TEEP agent to be configured to either protect privacy and require the 2 round trips, or to be configured to say, I don't really care about privacy and I'd rather be optimized for the round trips. And in that case, then you're opening yourself up to a potential privacy issue where you use a URL from the REE that's not trusted, and you'd send your attestation information to a TAM that you don't trust. And they may not even respond back to you, right? Or you could get a response back that's signed and the CA is not in your trust anchor list, so then you don't trust it, and you end the whole protocol exchange. But the trade-off here really is storage and privacy versus round trips and privacy.
And I support that.
In the protocol specs only send at least the current working group one, the OTRPV1 one, only sends the attestation information encrypted with the TAM's key.
Yeah.
So what happens is inside, what is it, line 6?
5. 5 is 7. Which
the
one?
message that comes from the TAM includes a key, which you may have cached, and that's what you're encrypting it with that TAM's
6.
public key. And so that's the current protocol's answer to the privacy question, is you only send it to somebody so it can't actually decrypt it, right?
Right, and in the discussion that Ming and I had this morning, we had a question about the trust anchor list and whether that included TAM keys or whether that included CA keys for the TAM.
Okay.
Yeah.
There's a presentation. Akira has a 10-minute slot later on it exactly. That's issue number 63. And
right.
So we will come back to that when Akira comes up.
Great.
Yeah. Yeah. And I think this is a good discussion because 2 points here. One is if you already have TAM certificate here, not CA, you know the trust right away. Then can you direct go to shoot for the single pass, right? Second one say, I have device, I don't care who knows my device ID, so what, right? Then the TEEP agent will pre-install there, most probably inside TEE. It configures say, when coming, I decide to give a sign request. Instead say, because this option, right? I could give a sign request direct to TAM, or I say, no, I just give you the URL, you can contact, I'll require you give me some data first. Both can happen. But this comes to our architecture, I'd say protocol scope, right? Possible. I think consensus or general ideas here is that we want to support this. Is our protocol should support such use cases, options. Then that's related to our schema. I would say schema, yeah, measure schema completeness, right? In the protocol spec, we will say what that means. This message here, right? TAM or signed. So this flavor. Yep. Good. This is a good discussion. Another one. This one talk about say a use case where I have a TA. We talk about it. We have 3 entities. Okay, 3 entities. I don't know the diagram here. You have server provider, you have TAM, and you have device. Server provider give a trust application to a device, right, through a TAM. Server providers are not always a TAM provider, right? As a particular case, I have many suppliers of software work with like this TAM, for example. TAM is a camera manufacturer. They put software into camera, but I have an AI model where you have the confidential information. I don't want even time, no. I don't want to give that IP to the manufacturer, right? Only I know. Then how do you deliver that to devices? So that's a case here. There's a case here. So note that one. First one, TA binary is encrypted from time to device. So you see earlier, okay, I'll just go back to the flow here. When TA binary is distributed from time is encrypted by device key. So only device can decrypt. This channel is end-to-end secure. What the top here has service provider behind this one. Do I have another diagram? Just a second. Yeah, this one. Server provider here. This diagram. Time will give the TA end-to-end security, but from server provider, how does server provider give a TA binary that time cannot decrypt? Time should not see it, because if time can reverse engineer the code, right? So that's the problem we try to address. We saw that's actually an interesting case, right? Trust application, not like it also deliver confidential IP there. So how to solve that problem? How to solve that problem? And our discussion come back is that case, time can deliver, your application can split between the binary, which is just the generate code, and confidential piece treated as a personalization data, right? You initialize the artificial intelligence model, your data model is as a data initialization piece. So what you have is that you have the time by manufacturer, reinstall your software, generic software. Whatever your AI model you have, you treat it as a data time, what's called data time, another time. But that time server provider, you will host it. So that way we can leverage the same time to device TEEP protocol without change. So you can address problem that way. Yeah, address that problem that way. So that's the proposal. There may be other solution to address this. So far, that's what we consider how to solve that problem, provide a valid IP protection scheme. Yeah.
So understand, this is the proposal from the editors, right? As to remember, the issue was introduced by saying we're going to remove security domain, and so the editors looked at all the use cases that security domain was providing, and this notion of security provider and said, well, we want to make sure that when we remove security domain and its related content, we don't actually break any use cases. And so how could you maintain this use case? And so they walked through all of these and they said, well, the way that we deal with this is to have the service provider for this particular case, they could have a second TAM and you can reference that from your TA or whatever it is. And so you can use exactly the same protocol without any changes. And so they said, well, we should just update the architecture document to explain that fact.
Yeah, this is a high level. We talk about the requirement. Is the architect doc we put as, yes, we support this use case. Support this architect. This is one for use case in scope. And we will talk high level, how can address this.
Good work by the editors. Unless there's any objections, then we can say, yeah, please update the architecture document to explain why you didn't break any of the use cases. And it does not require protocol changes.
And we can close the issue.
And then we can close the issue, yeah.
And I created an issue for that, 64, latest issue. Because we didn't have issue earlier, but we discovered a valid use case, and I will just track this way.
And I think the editors also talked about how you could potentially use it with confidential code. The example case is confidential personalization data, but the same thing would work either way, right? Whatever you can express in a suit manifest. Brendan explained during the Interim meeting, right, that many of you were at. You can use a suit manifest to express any files or any content, yeah.
Okay. Right. How does my time look? So
you're okay, keep going.
Okay.
You're on track. Keep moving. You're on track.
So this is so far. It's now that's pretty much the interim working session we had. Is a major topic. So I think there's a few good results from there. So this is good to other issue list. We'll talk about this one. Earlier, it's a TA dependent, not TA, and we discussed earlier. So how to do that one? It's a complicated, software dependencies can be infinite loop or very deep. But what we say was may suit work group is try to address similar problem. We will defer to that one. So what to do is a document wise, we should update reflect that. Then we can close the issue. Yeah. Multiple times for a single client app. Okay, just the example we said. One client app can depend. TA has binary and personalization. They can go to separate time, right? Even one TA can go to different times on TA. Yeah, multiple times supported by one. Yes, it's a valid use case. It's in scope. We support it, and then this was from last meeting. David, you want to say more about this one? No. Okay. So we just so we have document, David update document. We have this one support. We just say only thing I just note this one. Or to point out, you go to multiple time, but it's this one single time contacted by TEEP, right? So that means that type of all the other TAs you have. It's multiple time, but for given TEEP, you go to one. And the TAs supply their TA to that time. If it's a different times, that one time can talk other times, they collect all the TAs, just like Google App Store, collect all the App Store app in one place. You can download from one place. But if you decide to go to the Ali cloud, go to another cloud, that's fine, right? You can go to different places, but all together. I think this is a simplified decision. Just make things a little simplified. Not always really go to 100 different times, right? So that's a great burden there for one device. We reflected that in document. We just go to update. There was a one word change there, and then we're ready to close. Yep. Capability of attestations mechanisms. David, you'll talk more. You leave out tomorrow. So that's
right.
You'll talk.
I think
go
we
back.
should defer this.
Right. Go back. Okay. Dave Taylor, hackathon participant. We actually talked about this issue, and so I just wanted to relay to the working group that there is something that an implementation has to do with, and my belief was that it did not require any changes to the architecture document. And I want to share it here to see if people agree that it requires no changes to the architecture document. Okay. And so what this is saying is that if I have a client app, and the client app depends on two TAs, okay? Let's take a case where one of those TAs is already installed in the TEE and one of those TAs is not. Okay. Now, the one that is installed may have been obtained from TAM1, and the new TA needs to come from TAM2, or at least that's what the manifest says. Okay. So as an implementation decision, you have to figure out how you're going to deal with that, right? Does that mean that you want to ask TAM1, which is the one that you already got TA1 from, for TA2? Or does it mean that it's perfectly fine because I'm only going to be talking to TAM2 for everything, and I just ignore the fact that I got it from TAM1, right? The first TA, right? And so how do I deal with this case, I think, is an implementation issue, because I'm looking at the part in red here where it says a single TAM is contacted for a client app, right? If you say, oh, that one is already installed, okay, then of course I'm going to call it to one only for the missing ones, okay? Well, what if TA1 is actually right in the middle of the process of being installed, right? So you have these issues, race conditions. So how do you deal with that? In me thinking through it at the hackathon, I thought that this was an implementation issue and didn't need to be serviced to the level of the architecture document, but it's something an implementation would actually definitely have to deal with, because it could easily come up. I express a dependency on two TAs. One of them is already being installed or has already been installed from a different TA from where TA2 would do. What do I do about that? Okay, so that's the question. And I'm interested in David Wheeler's, I guess, opinion as to whether you think it affects the architecture or not, because right now I don't. I think it's a protocol or implementation issue. But
so this is Dave Wheeler. So the discussion that we had last time and what I was putting forward was that this problem really is a bit it's a bit manufactured. In a real ecosystem, when a service provider puts out an application and they publish things to a TAM, they're not going to publish part of the application to a TAM and part of the application to a different TAM. The whole application, including the TAs, is really going to be published to a single TAM. And they're going to provide a list of TAMs that they've published to. And so the likelihood that when you do an install, I've got to go to TAM A to get part of the app and TAM B to get another part of the app is really not likely to happen unless someone's really screwed up in the way that they're publishing their applications. Now, the other thing that you described, which is I've got this dependency, and so do I know that TA1 is fully installed and I have to go out and get TAB? That whole kind of multi-threaded issue is really a local issue. How does the TEEP broker and TEE know that something's happening?
Don't go away. Yes, I agree with everything that Dave said. The ecosystem point is if you have a particular TA that is out there that's like a third-party TA that two different client apps from different organizations want to depend on. Now, of course, in that particular case, I agree with the way that you phrased it, which is the client app vendor will pick a particular TA, a particular TAM, and that's where all of its dependencies will be. And so that just means in the ecosystem, this is a particular example where a particular TA could be retrieved. The exact same version could be done through either of two TAMs. Okay. And so that's why I think it's an implementation issue, because you can just assume that you only care about the ones that are missing. If the version number matches, it doesn't matter which TAM you got it from. Okay. And that's why I believe that it does not affect the architecture document. That it's just implementation, because it's as if you got it from the other TAM, because the hash will match. Right. Okay. You agree? I agree. Okay.
So I think an interesting perspective of this is how we deal with open source, right? So OpenSSL is a perfect example, right? A lot of applications depend on OpenSSL, but most of the time it's already installed on the platform, and you just have to make sure you've got the right version. And Suite's going to handle that for us. So in that case, if I don't have OpenSSL installed, my TEE version of OpenSSL, it'll get pulled down. If I do, we ignore it. And Suite's going to solve all those problems for us.
Maybe, but it might be useful to
We have a lot of expectation of Suite.
So David, may be useful to just annotate that in the architecture as the example for how it may become an implementation issue, not how Suite's going to solve everything.
So when talking this one, just point out one thing. One caveat. We talk about a single time contacted by TEEP broker, which triggered by TEEP agent. Remember what I talked earlier? Exception is this, data time. When we install something data and binary separate, you will go to two times, not one time. All right? So I think we'll add this wording in the architecture document to separate this one. When we install data time can be different, we'll treat differently. This one's more generically talk about, say, one application, multiple independent TAs, right? Different TAs. But if it's same TA, I have to split data and binary, and we will allow you would handle two times. And how to do that? I think that use case on both protocol and architecture, we need to illustrate this. This is a little bit exception to that, but we can categorize differently. Okay, just note that interesting problem. Yep.
Number 17, this discussion is the one that is for 11 a.m. tomorrow, so we're going to skip the issue number 17 today.
Yeah, this one.
Yeah.
Come on.
Dave Wheeler again. So we haven't talked about this probably enough. As you were discussing this, right? So the data TAM issue.
Data
right?
TAM. Yes, yeah.
So if a service provider is providing a data TAM, so they're issuing out the personalization data for applications, they have to scale their data TAM to be able to allow all devices that they're going to service to be able to come to their TAM and get that personalization data. In most cases, if they're going to scale to that level, they can also provide the bits for the application themselves.
So that's,
So I fall back to my previous position that I think that the service provider would probably just stand up their own TAM and they would have everyone come to them. Now there may be, I can envision a service provider TAM saying, I can deliver the bits for personalization, which is maybe 128 encrypted bits, but I can't give you the 2 megabits of the application, and then may offload that to a larger, more scaled out TAM. But I think in a lot of cases, if someone's going to do the effort to stand up a TAM, the likelihood that they're not going to have the bandwidth to service the entire application to their ecosystem is.
I was wondering whether they may dedicate to some more trustworthy TAM. Say, I'm not doing it, but I give it to a TAM provider I really trust. Not like a manufacturer in a different country, something. I just talk a lot here, right? But I may have a TAM with wholly hosted TAM. They have all the capability and scalability service, right? So you don't have to host yourself, but you trust that guy. You dedicate to them.
Yeah, I just want to be cautious of. Let's not make the protocol overly complicated in order to support going out to multiple TAMs. If that starts to become an issue with the flows, I don't think it will. I think they can be separate. But if we start to have issues with, coordinating different flows to different TAMs, we may want to rethink what we're doing.
Because if you do that, this push back to either server provider host TAM themselves to be that scalable,
right?
Or they will have to find the one they can trust. So you and me, right? I'll give everything to you, so you will, on the air, you will not disclose it.
Yeah.
So
okay.
So what I'm hearing in this discussion, I want to confirm that our understanding is right. What I'm hearing is that we don't yet think it's required to say that the broker needs to talk to 2 different TAMs in a case, right? Because we've talked about a couple cases here that I think Dave has brought up, where you can still do personalization data without having the broker talk to 2 TAMs, right? And a couple of those cases, if I understand right, is where the service provider hosts the TAM, the service provider contracts with somebody they trust to host the TAM for the service provider and things, and then there's the case, of course, where the binary itself is bundled with a client app, and so you don't have to do that, and so you're only going to the TAM for the personalization data in the first place. I think in all 3 of those cases, right, there's only one TAM that the broker talks to. And so I think what we're hearing is that we're not convinced there's any case in practice that we would actually need to talk to 2 TAMs. Is that what you're saying?
Yes,
exactly. That
history.
But now to come back to this one, just to revisit it here, as that brings it back. And now this one, that means this solution is not going to be used. Because this one talk about is that if you want to protect this AI, right, this is kind of example, AI model, that data will be given to TAM. You trust. You don't have to host. You don't know data TAM, because I should come back to this one. Because in this case, you talk to 2 TAM, right? Data TAM and binary bit tab. So if you talk the same tab, then this slide is, which is we want to risk that one. Say, for such IP protection, you find a TAM you trust, and you develop both binary and data there.
Right, and if you go back to the previous slide from last time where I talked about this, there's the 4th bullet under resolution. In the case where a TAM doesn't, only is doing the personalization, they can basically front a second TAM behind them to pull the information through. The only issue where that wouldn't work is if the data TAM doesn't have the bandwidth to do that, right? And I just don't see that as a barrier. Now, maybe in practice it is. Maybe I'm being too free with.
In this case, you say it's a binary TAM. Like the manufacturer TAM will be fronting the data TAM, right? Because that will have majority piece of the
either way.
Bigger.
Either way, it could be done, right? You could contact the data TAM, get your personalization data directly, and then it could front for the application TAM.
Yeah, it could. It's just in general, right? If the concerns that data time has less capacity,
Bandwidth. Right? You could do it the
bandwidth.
other way
So,
around.
Yeah, I think that this way, yeah, if it could, then that become proxy. Could, yeah, I think that data type give whatever encrypt data that front-end type proxy doesn't have visibility into
right.
it.
I think though, if you have the application TAM fronting the data TAM for personalization, you've actually created a man in the middle, so you may not really get privacy in practice, depending upon how we do the key exchange.
Yeah, yes, I was thinking about that because who's the TAM, right? Device attestation sent to which TAM when we're fronting. And
yeah, so I think we still need to think through this. I think we've got.
I think maybe need a little bit more chat offline before we finalize this one, right? Yeah. It's in here. It's I think it's a tricky issue. Yeah.
Well, what I'm hearing is that the two editors are still not quite converging, and it may not hurt to take it up to the mail list so that others can provide their feedback as well.
Sure.
This is Hannes. I was wondering whether, so when Brandon presented the suit work and how it applies to TEEP, to me, that personalization data concept that can be sort of like is part of the suit mechanism looked like a fairly simple mechanism that doesn't require the deployment of a data TAM, because the time when you create that personalization data and protect it, that's nothing specific to OTRP itself. And then when I hear the TAM terminology, I hear OTRP messages being processed here, and I see that more as the developer needs to find out, like, how do they want to package the whole thing, and how do they want to distribute certain things to nodes to a certain extent.
Yeah, we assume that personalization data, like our model, is something you won't put in a manifest file, right? Not put in a suit, because that would be a blob. It would bind a blob somewhere. You encrypt it by a device, you send to device from SP provider.
Mm-hmm.
Right, it has to be encrypted with a key that only that device has, or it's not defined by the definition of personalization data.
Yeah.
So you think by that it has to be OTRP sort of
part of a message,
real-time OTRP type of messaging.
It's part of that. Yeah, it will be it will be first-class data. Pieces.
It can still appear in the suit manifest. The problem is the suit manifest can't be constructed or can't be finished, or at least the content that is referenced in there, if it's a reference, right, can't be finished until you have the key that you get from OTRP, the device public key. Right?
Sorry, Nidal. I just have one worry about the scalability, because what happens when you have a very large number of IoT devices that you cannot serve by one time. You may need to split into multiple, because otherwise, all the scalability of sending the 2 meg, whatever you have to send, could be a problem. So I'm not sure that it's not a privacy; it's more of a reality of scalability. So I'm wondering what happened in that case when you have the same application but 2 times to talk to, because of depending on the region or whatever. So I'm not sure that case, the scalability in that case works. So.
You mean the question about the times capacity to support many devices? Well, this is assumption. Google, anyway, we host many internet services. We have billions of devices. That if you host a time service, you can design to support capacity. Right? That's an assumption here. Time service should do that.
Well, so the point is, it's just like I would do any other AWS service. So I would stand up a TAM in multiple regions on AWS. I'd put my
load balancer somewhere,
the same key, right? And I would use Amazon key management to share that key. Okay. So no matter where you were, it looks like you're talking to one TAM.
Yeah, one URL.
Got multiple instances.
One TAM, even if it's split because
exactly.
Not a one-time node. It's a one-time service, right? You have a URL. Yeah, it's a farm. It's a service farm. That way. Yeah. Okay. So now, this one we talk about. David Dealer tomorrow have dedicated slot for this. trust anchor. This is one of the also major topic, right? As an architecture level, right? Anytime you have trust anchor, we need to support life cycle, right? When you add more, delete older ones, whatever, right? But after all, what we roughly mentioned was that one. There's two questions. One is, does it fit into architecture document, or where should it be a separate document, right? That trust anchor, what format is, right? Trust anchor itself, and how to update the two issues involved, right? Issue 32 and 51 put together, right? What format, and how do you enable that update? At the same time, we notice that suit is a refer saying they may solve it. You have, but this one need more work. That way, more work. What banking here is suit is more for firmware update scheme. That's my understanding. Right? But trust anchor is key management. Yeah, trust root management. Like a browser have a root management, right? Chrome and Firefox, Mozilla, and so on. So that's a different problem, right? We have not done much deep on this one, but it's one for the open question, right? What's the open task or to do particular update time. So early in one of the hackathon, they will discuss with one side. We have special system TA, which has privilege to update the trust anchors, right? I can add a new certificate, remove a root, and so on. That's one way to approach it. But later, then someone mentioned about the suit which align with them. I think they need more follow-up. What is that even in scope for suit to manage the keys, root certificates? I have impression it's not that, but I think they need to follow up on this one.
As one of the suit chairs in the room, I believe that this same problem is shared by suit. Whether suit believes that it can be solved with a manifest format, I don't know yet. I think it might be, but I don't know what the working group thinks or even what the editors of the documents think right now. So, but I agree that the same discussion would be in scope for suit.
So what my more concerns about, as I raised it here, it's about the dependency. Well, all the line use it, but then that will be synchronized at a work group there. So we defer there, this work. Well, if we defer there in the architect document, whether we can close it or we have to wait there to finish this. That's two work group need to be lined for sure. Just for this one, whether we can completely defer there before they have defined.
I think the possible overlap where it's maybe in the intersection between TEEP and suit is if you consider the trust anchor store to be personalization data in the TEE, in the firmware part of the TEE, then it's squarely in the intersection between the two groups, right? And so both groups, I think, should discuss this question.
Okay. I need to follow up on this one. Just these two issues still open, I think, the major issues. Others I would talk about earlier, you can fail. I feel it's more less complex, and we're close to close those issues. We'll talk about this one. Install T single pass, talk earlier, and local TE signing. Talk about that one. I will just skip. This is the last issue I've talked today. It's we'll close this one. There was Anders could bring up a proposal. So can proposal about OTIP protocol itself, current protocol. He proposed a way use a session key based one. Use a binary protocol. It's a client side TEEP broker, or let's conceptually TEEP broker and TEEP agent API binary protocol. TEEP broker will translate the JSON message, the process there. Don't push it down to TE level. More importantly, he said he would like to have the TE and TAM use different Hellman, one kind of key change to negotiate session key. After that, future attestations based on the session key, because you can use session key at a future as they already attest, you're approved, right? Use the attestation proof. So that one, there's his proposal. He's like, can we move that direction? And we added the chairs or commented. We'll look at this one. First one will convey a dramatic change from current JSON CBOM based protocol, kind of a stateless, move to a binary protocol and use a session key to derive remaining attestation. Like our attestation try to leverage rats, right? Tomorrow talk about rats and use a manifest suit to that dramatic. It's a very different conception model with a dramatic change, right? Second one, the binary protocol versus JSON Seaborn protocol will also fail. This is more friendly, right? Friendly, easy to debug, easy to read. The third one is the patent. That technology is a patent. He would royalty free maybe, but it's a patent domain. So based on that one, we felt this all, we don't feel it's a comfortable go there. It's a lack of support in the editors, and then the filer just close the issue. So I do want to report all the issues we saw and give it back to this work group. And yep. So this is close and fine. So that's
that one. There's long silence after the issue was filed. It looked like there was lack of interest, and eventually, I think David Wheeler generated a response, and then I generated a response commenting on David's comments. But it didn't look like that there was support on the list for this, and so since the issue was already closed, it seems to be consensus. But if there's any objections, let us know, because the filer seemed to close it themselves, saying there seems to not be interest in doing this session negotiation. But there really were two different aspects of this proposal that are somewhat separable, right? One was the notion of having sessions, and I think that's the one that had the IP, the intellectual property associated with it.
Yeah, that's the one.
And then the notion of saying the protocol between the TEE and the TAM, as opposed to transport, is some binary format instead of JSON or CBOR, and just use JSON or CBOR as the transport for some binary format. That I think was an orthogonal point, that it combined both of those two aspects in this proposal. And we didn't see support from anybody other than the filer for either of those aspects. And so unless there's objections, this is already closed, but we're confirming consensus that there are no objections to closing due to lack of interest other than the filer. Hank.
Yeah. This is Hank, a little bit clueless about this issue because I haven't read it before. I really don't understand the binary protocol versus JSON/CBOR thing.
So here,
we didn't get it.
That aspect of the proposal, which was independent of the other one, at least as I read it, okay, was today we have OTRP carried in a transport.
Yeah.
Okay. By analogy, the filer's proprietary protocol used a binary, meaning the packet format diagrams, and
like a 2V stuff,
that between at the same layer as what OTRP works, and JSON or CBOR at the transport layer. Okay, so saying let's carry in JSON, and so the broker cracks out the JSON or CBOR, cracks out the binary blob, passes that into the TEE, and that the binary blob is what's passed between inside the TEE, right? That was his proprietary protocol that did that. Right?
Okay.
Yeah. And so he said, "Oh, well, I could do this in binary, and yeah, you still need a parser for that, right?"
Yeah.
So
no.
If that one is become more.
The comment that I posted to the list was on that aspect, saying, well, it seems to me like you're still going to have a parser, right? I didn't see an advantage of having a binary one over having a, say, well-vetted CBOR parser, right? Why does it matter?
Yeah,
right?
I see the point. Okay, thanks. And maybe Hannes has something.
Yeah, this is Dave Wheeler. Part of that discussion that I recall from the discussion with Anders was he didn't think that a JSON parser would fit in many of the small TEEs, which may be true, and there were security concerns around putting those full-fledged JSON parsers inside a TEE as well, and I think there's some validity to that. I think in many cases we're putting much more in TEEs today than perhaps even 5 years ago. On the session-based stuff, I had some discussions around. At Intel, we do have different attestations. We call them stream-based attestations, where we negotiate a session key and attach attestations to that negotiation. But that requires then that the parties to the protocol are two distinct points. And you can't flow attested data beyond that endpoint because the attestation is basically gone. It's part of the channel. So you're really no better off than maybe doing TLS and carrying some attestation during the TLS session. And so it makes it hard to build an ecosystem around the TAM when your data, once it leaves the pipe, is no longer attested to and verifiable. So that's the reason why, from my position, we didn't want to go with a session-based attestation. We wanted a token-based, as we talk about with RATs, where the signature is attached to the data you're passing back and forth.
This is Hannes. I think the interesting part of the conversation was the question about what do you put in the normal world versus what are you placing in the secure world. And my I discussed this on the list with Anders, and I don't see how you maintain the functionality and security and then still not put most part of the code into the secure world. That's what I couldn't come up with a story. While it sounds nice to just do the crypto operations in the secure world, but then what's the semantic of all of this? If you do the rest in the normal world, and the secure world essentially just signs or encrypts some hashes, and that makes me still makes me wonder of how this is supposed to work. But if someone of you has some ideas on how to better make that split and put fewer code into the trusted information base, of course, that would be really great. Having said that, the new version that I put together for presentation tomorrow actually has fewer messages and much less functionality. So by that, it already has a much smaller trusted information base.
So I will add into that the binary protocol versus JSON CBOR protocol. I will argue that is not an architecture document issue. It's an OTRP issue. And tomorrow, in Hannes's presentation, we will talk about OTRP, where I thank you, David, for summarizing Anders's issue with, say, JSON inside. And we'll talk about using CBOR as the current proposal to solve that at the protocol level, not at the architecture document level.
But I accidentally CBOR because I didn't figure out how to do it.
Yeah, it's no. Hannes will talk about tomorrow. The OTRP v2 proposal supports both JSON and CBOR, but even before that, we have had discussions in this working group that says we should probably want to allow CBOR as an option. That's come up in a number of different meetings, but that is not something that's an architecture document issue. We will come back to it tomorrow.
So I would add that this one issue actually is a proposal raised 3 years ago, actually a long time ago when we did the OTIP in the beginning. So what we looked at it, right? If we look at it, it's not a good fit. There's another reason. So, scope-wise, this session scheme was for secure key provisioning. If you look at the protocol, it's called SKS, secure key storage. That what you put in secure element, a smart card. It's more addressed the security key provisioning. But this TEEP is more addressed the trust app management, it's application management, not only for the key provision. It's not key management protocol. That was really addressed for the key management protocol, for key storage into HSM, in secure element, and so on. So it's a different flavor, right? It's strongly relies on that one, because that analogy go back to the other work, kind of have a key prof, right? He points that key prof, key provision work group early in IETF. We have, yes, it's a 3-phase, right? 3-phase provisioning key into device. Yep. That way you use a session key, which will all address the key management. This one's application management. We don't want to really focus that one, use that one. That's where the binary go to API called lower tier. You want to really go to silicon level. So it's a different. I didn't elaborate much here, but as a main one in high level, you see it is a application management versus key management. That's where it's not a great fit, right? Okay.
Thank you. So we have one more issue, and Akira is going to come up and present the last of the GitHub issues for today. So thanks, man.
Okay. Thank you.
This one's what, issue number 65, I think, in the tracker. It's in the agendas.
Hello, this is Akira Tsukamoto, working for AIST, which is a Japanese national R&D organization. And the reason I made the slide yesterday during the hackathon with Suzaki-san and Isobe-san and Dave and Hannes and Ming, all five was. Can I go to the next slide?
Yeah.
Yes.
Yeah. Oh, I pushed the button. I see. Okay. So these are some of the slides where to put the keys and certificate and CAs, because this documentation for TEEP architecture draft is trying to be made to be generic as possible, not binding to any particular CPU, not trying to bind who is the developer of TA, or who is the developer of the service provider, or who is developing a TE. And so TA could have multiple TAM, or considering many different kind of situation. For example, client could have many TA or many situation. So the page goes to 37, written as generic as possible. And then when I try to think about how to extend our initial prototype implementation, I got confused. First 10 pages of knowledge is disappearing from my brain. So try to enumerate on the slides. So when we enhance our initial prototyping, we won't put it in the wrong location of the keys and signature and CA cert. So in this first one is, and first diagram and second diagram is pretty much doing the same. Which TA could be loaded and verified and run it, execute it. And in the TEEP architecture documentation, TA must be signed by service provider and need to be verified from TEEP agent or TRP agent. So which word is going to be used in the documentation in the future, I'm not really sure. Both?
So far, architecture
TEEP agent.
Oh, TEEP agent.
TEEP agent.
Okay.
Actually, that was one terminology. We try to align with TEEP agent, but product document so far, we get a product one for protocol. If you have three protocol in future, do we call TEEP agent? Currently it's an OTIP agent, but we try to come with TEEP agent. Anyway.
The architecture document and transport document use TEEP agent, and so that's the one we're moving to. And so not all documents are updated yet, but those two are moving.
Yeah.
Okay, thank you. And so another motivation of making this slide was writing the code on TE side, especially on ARM. It's not easy to write a code on the RE side. Most of the doesn't have much rich system call or library, massive library. You could easily use it on TE side. So if I miss it, starting the implementing in something in RE side and later I have to move it in TE side, it will cause a lot of headache. So, and pretty much the same. It's how the TE is going to be done in the RISC-V too, which is our objective of running TE on RISC-V and having TE absolutely working on RISC-V too. So and the second one is my understanding of Intel SGX and ARM trust zone, at least on OPTI, TA must be signed by TE to be loaded and executed. So
I'm going to jump in here partly because you take my name on the slide. The previous slide was the one that was about what's allowed to be loaded
Oops.
This slide is actually about the one with the red, the one with the green boxes is about what's allowed to be loaded, right? And so the SPCA cert is whatever is in your loader, whether it's opt-t or your launch enclave or whatever. On the red slide, this is about the keys that happen when you are loaded that are used for attestation or evidence, right? Because if it chains up to a hardware root of trust, this is the keys that are used in the dice chain, which is used for attestation, right? This will relate to the discussion we have tomorrow when we get into the RAS discussion, right? These keys are not used for loading. This is when you do get loaded, you get measured, and this is what is then used to feed into your attestation information. So I just wanted to correct what the dice chain is used for. It's not used for to decide what loads. It's when you load, you generate the dice chain.
So Dave Wheeler, I'm confused on this slide with the red, where the TA is signed by the TEE private key. Even in an attestation flow, right, the TA should be signed by the service provider that developed it. Now the agent.
You end up with two different cert chains. One's used for attestation purposes.
But in an attestation, I want to know who wrote the code, right? So
okay, I'm going to declare that part of tomorrow's scope.
Okay.
And so maybe this particular slide we can come back to after 11 tomorrow. We do have at least one of the participants. I see Hank is in the room, who's one of the people that we want to, that's only going to be there after 11 tomorrow. And so it's probably for Hank and anybody else that we advertise to RATS, saying if you want to be part of this discussion, come at 11 tomorrow. And I expect those are the people that want to be involved in this discussion.
Okay.
Well,
so we are welcome to come back to this when we come back to your issue number 17 discussion. You're back up here. You're welcome to regenerate this, and if you want to refresh this tomorrow, that's fine.
To me, this is interrelated. That's part of this issue number 17. Yeah.
Right. It is related to you, but it's a different thing from the green slide.
Yeah.
Yeah, I'm glad I put it in the slide because this is something I was also confused with the first page and the second page.
The architecture document used to unconfuse us.
And there's only 2 more slides. Yes.
So can I ask, where are the blue sheets right now?
Huh?
Is there anybody that has not seen the blue sheets? Okay, if you can say, pass one of that. Raise your hand again if you have not seen the blue sheets. Okay, thank you. This is our 12-minute warning. Please send the blue sheets over. All right, carry on.
Wait, one question to Akira.
Yes.
Have these issues been posted to the GitHub?
Yes, this is issue 65.
Okay.
Yes. I just post a PDF on the GitHub. Paste it.
I'm just trying to correlate.
I'm still unclear what the issue is.
The issue is that some of the implementers found the document unclear about which keys were in which location, and they were trying to correlate between the table in the architecture document and the diagram in the architecture document, and we're having problems correlating the two.
So this is
just editorial issue.
Yeah, this is a main page. So I just add that one. So architect document, I have keys certificates in a table. In a table says a client device TAM, but not in a, I think one enhanced diagram shows really boxes where with stuff. So enhanced document.
It might be useful to just label keys, right? Keys for attestation, key for image signing, ...
Yeah, that's all. I saw the when they in hackathon, that was hackathon helpful. We talk through it. So when audience feel this way to understand where it is, and it means a document need a better way to illustrate it.
The implementers are preparing slides for their own purposes and sharing them with us to say, is this right? Is this what the document means? We said, that looks interesting. You should present these slides to the working group, and if everybody agrees, then we at least know that everybody has the same understanding of the interpretation. So
yeah, there was a placeholder there, but just today, so whether it go to next level. So this is like sign for one.
Okay. Yeah, just trying to clarify page 19 of this ASCII chart. Yes, and the third slide is. Most of the ORTRP documentation talks about how to pass the ORTRP binary format between the TAM and TEEP agent. So, and then, yes, and the discussion yesterday is pretty much was obvious that TAM private key and CA cert is on TAM and the opposite on the TEEP agent. And this was yes, it was pretty straightforward
and clear.
Yes. In this slide of discussion, we're not talking about trust anchor update or anything. Just when we start the message or when we start the TA or generate the TA, where the key will be and how it will be verified. And the last one is, I'm not particularly sure does it match in the architecture documentation, or whether it's going to be really used as it is in the implementation. But my understanding was OEM will have TFM pub and private key pair, and the device will have a private key, and then the TAM will able to verify the device with it.
I'll give a comment here because yes. I have an original author on this one. TAM trust device, attestation, the TAM trust device. First one, you trust TE key, right? TE certificate, chain into a TECA. You have that one in last slide, OTIP, TECA. Optionally, optionally, we have said that TE when installed is from secure boot, right? Firmware, TWK is a trusted firmware. Trusted firmware key will sign TE. So that TE loaded is from secure boot and from secure trust firmware. Even that can have a certificate. Later time make a decision. Say this is a device which run TE, which is further secured by secure boot. So you have two trust level. You trust TE itself. Also, optionally, demand or mandate whether you want to say you must give me trust firmware assertion. But when this protocol gets to the last few sessions, right, IETF, we are retiring the trust firmware requirement because some TE do not have it. Right, it's not it's not normal, so normalized. So that was, I think we are going to put out from the tech document. So if you go back to the last slide, you can see that TAM always have a TECA keys there, right? That's what trusted, right? TECA. You trust the device attestation based on the device key. Firmware was optional in the old document, but the new one we are making the way out, so that will be updated.
So this is Dave Wheeler. Let me agree with Ming. I think the trusted firmware is probably still going to be an example. So if you go back to your previous slide, this is going to be the trust relationship. So the TEE will have a private key, which the TAM will trust. In the implementation, we will talk about the next slide where you have a trusted firmware, and your TEE private key will have a route that goes back to a trusted firmware key or something. So the key for the TEE may be itself just a single key, or it may be part of a trust chain. And the trust chain is just an implementation option.
A trust chain is from ROM bootloader, first bootloader, and then UEFI or UU boot, and then yes,
right,
and TE, and yes,
and in some of the hardware-based TEs, it may appear as though it's a single key in the TEE, but it may actually be derived from other hardware keys through different processes as well. So it may not actually expose itself as a certificate chain, although it may be some sort of hardware chained key. So, and we'll try to explain that better in the architecture document. We haven't gotten to that stage yet, and that's probably where a lot of the confusion lies.
Oh, thank you. And this is the last slide. Thank you. Yeah.
Thank you. Okay, so unless there's no other orders of business, we're running out of time. So what we're going to do is we're going to move the hackathon report. And so I'll update the agenda. Transport. That's right. So the transport presentation, we'll start tomorrow's session with the transport presentation and then proceed with the agenda as presented tomorrow. So if anybody has not signed the blue sheet, please do so. Otherwise, we are done until tomorrow. Thank you.
Yeah. You want to join us for lunch? We have plans.